So Aileen and I did our project over the planet Mars. These are our sources, and that's a picture of the very famous candy bar, a Mars bar. Mars's average distance from the Sun is 142 million miles away. Mars is the planet after Earth. It is called the red planet. Its true color is a brownish red on its surface. Its rotation around the Sun is 249,232,432 kilometers. That's 1.639 times that of Earth. And that's a picture of Mars's true color. Mars's surface and crust is made mostly of iron-rich bastelic rock. That's similar to Earth's thin crust. Its mantle is made from silicate rock. Its core is made of probably an iron, nickel, and sulfur core. Whether it is not hot liquid or cooled metal is not known. And that's a picture of its chemical composition. Mars is divided into 3 layers: crust, mantle, and core. Scientists can make predictions as to the thickness of the planet's crust based on the depths of one of its craters, Valles Marineris. Estimates put its thickness in the northern hemisphere at 35 kilometers and 80 kilometers in the southern. The core is mostly solid based on Mars's magnetic field, but is also partially liquid. At some point in its history, it had a full liquid core. And that's a picture of Mars's crust, mantle, and core. Mars is marked by very interesting features. Some of those like on Earth and some very different. Some of those features are volcanoes, canyon systems, riverbeds, cratered terrain, and dune fields. The reddish color of Mars is caused by rust, an iron oxide in the soil. Mars hosts the highest peak in the solar system, Olympus Mons. It rises 75,000 feet above the surrounding plains. It also has a giant canyon called Valles Marineris that runs across 2,005 miles across the surface of the planet and reaches depths of 4 miles. And that's a picture of the rocky surface of Mars. Mars's diameter is 4,220 miles. It's the second smallest planet in the solar system behind Mercury. If you weighed 100 pounds on Earth, you would only weigh 38 pounds on Mars. It would take more than 6 of Mars to fill the volume of Earth. Mars has about 1/10 of the mass of Earth. On Mars, you'd experience 62.5% less gravity than you're used to. And that's a picture of Mars and its moons. Mars's eccentricity is second largest among all the planets, similar only to Mercury's. Evidence shows that this high degree of eccentricity has not always been present, and it may have been less than Earth's at some point in history. Of all the terrestrial planets, Mars is the only one having a year that lasts longer than Earth's. One Martian year is equal to almost 686 Earth days. It takes Mars about 24 hours and 40 minutes to complete one full rotation. Mars experiences seasons like those on Earth, but substantially longer. And that's a picture of Mars's orbit compared to Earth's. The tilt of Mars is 25.1 degrees. The atmosphere's main gases are carbon dioxide 96%, argon, nitrogen, oxygen, and carbon monoxide. It also has other gases in small amounts called trace gases. Did you know that carbon dioxide is used for carbonation in beverages? Frozen carbonation is dry ice. Argon is used to make blue neon lights. That's a picture of Mars behind Earth. Surface temperatures at the winter pole range from negative 113 degrees Celsius. Surface temperatures at the summers range from 0 degrees Celsius. The average temperature of the atmosphere is negative 63 degrees Celsius. And that's a picture of the temperature of Mars. Mars has 2 moons, Phobos and Deimos. Mars does not have any rings around it. Mars's moon Phobos is 9 kilometers long, its radius is 11 kilometers long, and its mass is 1.08 E16. Mars's moon Deimos is 23 kilometers long, its radius is 6 kilometers, and its mass is 1.08 E15. Both of these were discovered by a man named Hall, and they were discovered in 1877. That's a picture of Phobos and Deimos. The second picture is Phobos compared to Mars, and the third picture is Deimos compared to Mars. Mars is the 4th planet from the Sun. With the little exception of Earth, Mars is capable of hosting life. Many missions are planned to see if people from Earth could live there someday. Martians, extraterrestrial creatures from Mars, are featured in many science fiction books and movies, and one example is The Martian. Mars has seasons like Earth, but they last twice as long because of its tilt. The month March derives from the planet Mars, and this is a picture of the film The Martian from 2015. Every time scientists feel closer to understanding Mars, new discoveries send us straight back to the drawing board to revise existing theories. Conditions on Mars vary widely from Earth. Today's Martian wasteland hints at a formerly violent world where volcanoes once raged, meteors plowed deep craters, and flash floods rushed over the land. One of the main discoveries scientists have made by traveling to Mars is that there's a possible presence of liquid water on Mars, either in its ancient past or preserved in the subsurface today. And that's a picture of the Mars rover. Now here's a video of why so many people want to go to Mars.
The reason humans should go to Mars is because we're human. I mean, we are an exploring species. It's what's made us the dominant species on this planet.
If we only lived in one little plot of land on Earth, we never went anywhere, I would say let's explore. I need a good reason to cross this ocean. Well, because we haven't done it before. How's that for a good reason? We might learn something tomorrow that we don't know today.
You know, there's an old saying, why are you climbing that mountain? It's because it's there. Because I want to do that.
It's what we do, we explore as human beings. And so going to Mars is an obvious next step.
It's the great beyond in the most literal terms, right? It's the great beyond.
We humans love a target. We love to have something to shoot for, to aim for, and to build a plan to make happen. And Mars has that sexiness, that romance. I think it's galvanizing a lot of people right here, right now.
For me, it's just a curiosity. As a human being, I'm curious. You want to know what's beyond that horizon.
Curiosity has actually fueled most of the great achievements that we've made in the world, especially through technology.
If there's a place you've never been, there's a scientist who wants to know what's there. Just the curiosity of inquiry.
We can understand the evolution and formation of our own solar system. We can start to understand how planets form and how they evolve. And we can also start to understand, the distribution of life in the universe.
We're looking for life. So when you ask people, why are we going to Mars? Number one reason is because we're looking for signs of life elsewhere in the solar system.
And imagine if we can find that there are actually some cells or some signature of life on Mars. That would be game-changing in our thinking about our position in the universe.
One of the things that happens when you go into space, and all the astronauts have talked about this, is that it changes your perspective about the Earth.
The human experience of actually being there will be revelatory in ways we can't even imagine at this moment.
The true awe of, hey, who are we in this universe, and what can we learn about it, and what can we therefore learn about ourselves, I think is a really great reason to explore.
One of the reasons that I really like is not seeing Mars as a challenge to overcome, but to see Mars as an opportunity to unite people together in a peaceful way. We can give not just ourselves, but our culture and our society and our species a goal, and can unite so many different types of people together. You're actually addressing fundamental issues on Earth by giving people something optimistic to pursue. And that's why I want to see us go to Mars. And I want to leave that as a legacy for my children and for the next generations of our species.
And that is our presentation. Thank you very much.